How do you remember lens diagrams? Well, today we look at simple ways to remember those lens diagrams, not by cramming with our mathematical scale diagrams, simple calculations, and observational patterns, the things that make up science. So let's begin. An object placed at F. An object placed at F has the same object distance as the focal length, as seen in our example. For each question given, we will draw a lens diagram, use our lens formula, and make observations about what our image should be. It is imperative at this point to note that we end up with a fraction with a numerator of 0, which represents the inverse of our image distance. By inverting both sides of our equation, we will end up with v equals some value over 0, which ends up being undefined. What does that mean? This means that the rays exit the lens as parallel rays, or are drawn as parallel rays of light. And parallel rays of light never meet, meaning that an image cannot be formed because these rays can never converge. Now, knowing this, if we reverse the situation where parallel rays of light enter a converging lens, they will converge to form an image at point F. Those are therefore 2 of our 6 diagrams. Our second example is an object placed beyond 2f, also known as between 2f and infinity, since any distance beyond 2f is considered to be an infinitely large distance in comparison to the size of the lens. Now, in our example, an object is placed 26 centimeters from a converging lens, which has a focal length of 10 centimeters. Here, once again, we will observe when images will be formed using our lens formula. By our calculation, we see that the image will be formed between 2f and f. In this case, 16.3 centimeters. On our graph paper, as with the previous diagram, we will get a scale diagram in terms of what our image looks like, whether it is inverted, enlarged, virtual or real, etc. Once again, let's reverse our object distance. If we place our object between f and 2f, where will our image be formed? Well, beyond 2f, as seen in our diagram here. Now, there are many people of the misconception that convergent lenses only form real images. While this may be true generally, there is one special case in which a convergent lens can form a virtual image. We look at that special case in this example below. When an object is placed between the optical center and focal point f, a virtual image is formed. What's interesting here is that we get a negative value for our image distance. But don't panic, because a negative value for our image distance really gives a hint that our image is actually virtual. What does a virtual image look like on a lens diagram? Well, unlike real images where the rays of light actually meet, virtual images are formed from rays of light that appear to meet. So how do we represent this? We use dotted lines, as seen here in our diagram. By now we are quite familiar that our undeviated ray, which passes through the optical center from the tip of the object, is always drawn for each lens represented. But what happens here is that at the very top of the object, a ray of light is drawn across to hit the top of the lens to show some sort of refraction that occurs and spreads out slightly on the opposite side, in this case the right hand side of the lens. Those two rays are extended to meet on the left hand side of the lens, in this case on the same side as the object. We use dotted lines to represent this, of course. Where they do meet, a virtual image is therefore formed. Notice that the image is upright. It's on the same side of the lens as the object. Now we look at images formed using diverging or concave lenses. Now it's important to remember that via the sign convention, the focal length for divergent lenses is negative. Here we see that our image distance is once again negative, meaning that our image is virtual. I do hope that you enjoyed this video, and I hope it was helpful in remembering your lens diagrams. Feel free to ask any questions below. Please draw your diagrams on graph paper so that it will make a lot more sense, and remember to teach someone what you learn. If this video was helpful, click like, and for regular updates on weekly posted videos, you can subscribe to Ethereum Physics, where we continue to question, discover, and learn about physics.